Friends, imagine you have a piece of paper, and when you stretch it, it tears. Now, imagine if you make those pieces of paper even smaller, there will come a time when you won't be able to divide it further, and perhaps that piece of paper will be so small that you can't even see it with a naked eye. This small individual particle is what we call an atom. Let's understand it with another example. When you try to look at chocolate under a microscope, you'll see tiny particles. But behind these tiny particles lies an important secret, the atom. So, today, in this chapter, we'll study atoms and molecules in detail through amazing visuals and animations. So, let's get started. Before studying atoms in detail, let's learn about some laws, which are the laws of chemical combination of atoms. The first is the law of conservation of mass. This law states that mass can neither be created nor destroyed in a chemical reaction. For example, when we burn paper, it burns and turns into ash. In this process, the total mass is conserved. This means that if we measure the mass of the paper before and after burning, it will be equal. The second is the law of constant proportion. According to this law, to obtain any substance, we must mix the ingredients in a fixed proportion. For example, when we make bread by mixing flour and water, we must follow a fixed ratio. If we add too much water or too little flour, the bread will not be made properly. This is the law of constant proportion. Consider another example. To form the compound of water, we need hydrogen and oxygen atoms. This law states that one molecule of water contains 2 hydrogen atoms and 1 oxygen atom, which are found in the ratio 1:8. We call this fixed ratio H2O, meaning water. This means that in a chemical substance, the elements are always present in a definite proportion by mass. This is the law of constant proportion. However, there was no explanation for these two laws. Therefore, scientist John Dalton explained it using Dalton's atomic theory and provided some important postulates. The first postulate is that all matter is made up of very tiny particles called atoms. This means that any matter is made up of very small particles, which we call atoms. The second is that atoms are individual particles which cannot be created or destroyed in a chemical reaction. This means that atoms are individual particles. This means that we cannot divide them, nor can we create or destroy them. The third is that atoms of a given element are identical in mass and chemical properties. This means that the mass and chemical properties of any element's atoms will be identical, meaning they will be similar. For example, the element sodium. All its atoms will have the same mass and chemical properties. It's not the case that one sodium atom behaves differently and another atom behaves differently. The mass and chemical properties of all atoms will be the same. Fourth, atoms of different elements have different masses and chemical properties. This means that atoms of different elements have different masses and chemical properties. For example, hydrogen and oxygen atoms will have different masses and different chemical properties. Fifth, atoms combine in the ratio of small numbers to form compounds. You can connect this to the example of making water. For example, to make water, we need to follow a ratio of 1:8. Only then will we get its compound. Sixth, the relative number and types of atoms are constant in a given compound. This means that the relative number and types of atoms within a compound are always the same. For example, if we consider water, or H2O, there are always 2 hydrogen atoms and 1 oxygen atom present, making it a water compound. Now, it's time to learn about atoms. So, what exactly is an atom? The building block of all matter is called an atom. This means that the smallest unit, or fundamental unit, of any material is called an atom. For example, if we tear paper into small pieces, there will come a point when we can no longer divide it further. We call the smallest part of that paper an atom. But how small are these atoms? Compare it to an ant. The size of a normal ant is 10 to the power of -3, or 1,000 of a meter, and the size of a hydrogen atom is 10 to the power of -10 meters, or 1/10 of a zero. So, you can't even imagine how much smaller an atom is compared to an ant. We express the size of an atom in atomic radius, which is expressed in nanometers. 1 nanometer equals 10 to the power of -9 meters. You probably can't even imagine how small this unit is. Our next topic is modern-day symbols for different elements. As we learned in Chapter 2, elements are pure substances. In this topic, we'll learn how atoms get their names. For this, the IUPAC, an organization, approves the names of elements, their symbols, and their units. Accordingly, the first letter of an element is always capitalized, and the second letter is always lowercase. For example, aluminum is represented by the symbol L, where A is the capital letter, representing the first letter, and the second letter is lowercase. There are many elements whose names are given by their first letter. For example, calcium is represented by Ca. However, this is often inaccurate. Therefore, some elements have names derived from German and Greek. For example, iron is represented by the symbol Fe. Potassium is represented by the symbol K. Therefore, we can say that each element has a name and a unique chemical symbol. Our next topic is atomic mass. So, what is atomic mass? The mass of an atom of an element is called atomic mass. That is, the mass of an atom of any element is called its atomic mass. We measure it in AMU, or atomic mass units. 1 U equals 1/12 the mass of one carbon atom, and we also represent it with the symbol U. I'm going to mention the names of some elements. You should memorize their atomic mass as well, as they are very important and are widely used in physics. For example, a hydrogen atom has a mass of 1 atomic mass unit. Second, carbon 12 atomic mass units, nitrogen 14 atomic mass units. Then oxygen 16 atomic mass units. Sodium equals 23 atomic mass units, magnesium equals 24 atomic mass units, sulfur equals 32 atomic mass units, chlorine equals 35.5 atomic mass units, and finally, calcium equals 40 atomic mass units. If you want to know how to calculate atomic mass, please leave a comment in the comments section below. I'll make a next video on this topic. Our next topic is molecules. So the first question is, what is a molecule? A molecule is, in general, a group of 2 or more atoms that are chemically bonded together or lightly held together by attractive forces. This means that a molecule is made up of bonds between 2 or more elements. There are many elements that don't exist alone. For example, a single oxygen atom never exists. We always write it as O2, meaning oxygen gas. Similarly, 3 oxygen atoms are called triatomic, meaning ozone gas. The number of atoms in a molecule is also called its atomicity. When 2 or more atoms of different types combine, it is called a molecule or compound. For example, H2 becomes CO2. One topic within this is ions. So, what is an ion? So, whenever an atom or molecule has a positive or negative charge, we call it an ion. A negatively charged ion is called an anion, and a positively charged ion is called a cation. For example, sodium chloride, where Na, or sodium, has a positive charge, and Cl, a negative charge. You might be confused about the charges here, wondering how these charges are applied to the elements. So, you'll need to be a little patient, as we'll discuss this topic in the next chapter. To understand this concept, it's crucial to understand valency. We'll discuss this in the next chapter. For now, memorize the table I'm giving you, as it's extremely important and will help you greatly in compound formation. Our next topic is writing chemical formulas. This topic is quite important from both your exam perspective and your chemistry perspective. We can also call it the basics of chemistry. It's such a crucial topic that if you ever study chemistry in the future, you must know how to write chemical formulas. Without it, you won't be able to solve questions. I hope you understand the essence of this topic and are fully focused. So, to write chemical formulas, you need to know three things. The first is the concept of atomic number, the second is valency, and the third is electronic configuration. I think these terms will sound quite new to you. And it's possible that when I explain them to you, you might not understand them a little bit because the core concepts are in your next chapter, Structure of the Atom. There, you'll learn in detail about what valency is, what atomic number is, and what electronic configuration is. In this chapter, I'll give you an overview of all these topics. But for that, it's crucial to memorize the table I've provided. I hope you've memorized it. First, we'll learn about valency. So, what exactly is valency? The combining power and capacity of an element is known as valency. The combining power of any element is called valency. For example, sodium has an electronic configuration of 281, giving it a valency of 1. Chlorine has an atomic number of 17, giving it an electronic configuration of 287, giving it a valency of 1. If you want to learn more about valency, you can refer to the next chapter. You can read the next chapter first and then look at this topic. So, first, we'll learn how to construct the chemical formula for sodium chloride. For this, you'll need to know its valency and electronic configuration. For example, Na has an atomic number of 11. Its electronic configuration would be 281. Na, i.e., sodium, has a valency of 1. Chlorine, whose atomic number is 17, has an electronic configuration of 287, with a valency of 1. Simply crisscross their valencies, resulting in a net valency of 1, resulting in the compound sodium chloride. Similarly, we'll look at the chemical formulation of HCl, i.e., hydrogen chloride. Hydrogen has a valency of 1, and chlorine has a valency of 1. Simply crisscross their valencies, resulting in the compound HCl. Consider another example, ammonium sulfate. We write ammonium as NH4. Sulfate is written as SO4. Ammonium has a positive charge of 1, and sulfate has a negative charge of 2. I hope you've memorized this table. Now, if we simply crisscross their charges, we get the compound NH42 and SO4, which means ammonium sulfate. Solve all these questions similarly. I hope this video has provided you a lot of value, friends. If you liked it, please like it and subscribe to our channel to receive notifications of our upcoming latest videos. See you in the next video. Till then, goodbye and keep learning.